begin.
All right, you guys, we're going to go ahead and move into your molarity assignment now. So you should have watched the previous video where Mrs. Egan demonstrated making the lemonade with you guys. And now we're going to walk through this packet that you guys are able to now access on Teams Online. So we're going to go ahead and use the examples that Mrs. Egan had with lemonade solutions and mixtures to go ahead and work on solving this problem. So if you look at model 1 on your guys' paper, it says lemonade solution 1. In this solution, if you look at the picture, it is lighter in color compared to solution 2, and that's kind of one of the differences visually that you can see. But what you notice is in this little circle, it's showing you a detailed view of what that solute looks like inside. So if you notice, there are 3 little dots of solute, meaning it has a low concentration of solute. And if you look at the example of lemonade over here, you can see by the lighter color, there's definitely less of the solute of the lemonade inside that cup. If you look at the example of lemonade solution number 2, you notice in this little circle, if each dot represents the solute of lemonade, there are way more dots or a higher concentration of that solute mixed in the lemonade. So if you look at Mrs. Egan's sample over here of number 2, you can definitely see the difference in that amount of solute inside that cup of lemonade. This would taste way more tart, and this one way more watered down because it has a lower concentration. So I went ahead and just gave you guys the answers to this part if you were listening very carefully to the terms that I used. And you can absolutely reference your molarity solutions and notes on 3.08 to go ahead and define some of the answers to some of these terms if you are struggling with those ones there. We would like you to complete the whole side of this page. Moving on to the back of that first page, the same thing goes with the first question. That should be easy for you guys, especially looking at the differences in the cups that you guys see in front of you. And then question number 3 mentions lemonade solution 2. So we're looking at this solution, if it's considered to be concentrated or not, or if it's considered to be diluted compared to the other one. So you're going to look at those 2 pictures, go back to your terms and look up concentration and dilution, and make sure you guys can explain the difference. In number 4 and 5, those are pretty easy questions as long as you refer back to the pictures that are on the page 1 or your sample cups that you guys have here. And remember that it's going to discuss the terms concentration and dilution again down here on number 5. Keep in mind that those terms can be looked at different ways dependent upon the color of the substance that you are also adding and the intensity and deepness of that. This is where we figured you guys would need a little bit of help when we're moving on to the mathematical part of figuring out the solution in moles. And so if you take a look here, it says dilute. And if you look at these pictures, you notice that these are 2 diluted examples where the concentration is way less with your solvent particles. And on the right-hand side, these are the concentrated, where you can look at the amount of particles are definitely increased in these pictures. And we went ahead and gave you the outline for the mathematical formula, the examples here and here for you guys to use, but I'll go ahead and I'll walk through the first one with you.
And why don't you write down, Mrs. Ammon, why don't you write down what molarity is in a equation?
Absolutely, Mrs. Egan. So molarity is equal to the moles of the solution,
Moles of solute.
over a liter of solution. And so definitely right now, you guys go ahead and write that equation down on your paper. You guys are going to want to have that. And if you look at the sample we have over here, it's just flipped around. It's just putting molarity on the other side. So we have 1 molarity is equivalent to 0.06, and we're talking about liters of solution. So that's this 0.06 liters of solution. So 0.06, you could put liters here if you guys would like to. And then on the top, you have to have the moles of the solute. Well, if you look at the rest of the equation that we have left, our moles of our solute are this 0.06 moles of copper chloride. And so if you put 0.06, and you can put mole of the copper chloride, and if you divide 0.06 by 0.06, you will get 1 mole. And that is going to be the answer to that equation. You will complete that same formula for these other three problems, but we are going to give you one more example down here. So remember, the equation says moles of solute on the top. So we have down here 0.18 mole of the solute glucose. And so you could put moles of glucose if you would like. And on the bottom of the equation, we have liters of solution. And so we have the 0.06 liters of the solution. So then you would put 0.06 liters. 0.18 divided by 0.06 is equivalent to the 3 moles. So using that equation and outline that's up here for you guys, you will also complete these other three equations. Moving on to that back page. So number 6 asked you guys to list the beaker numbers for the solutions in Model 2 that are considered to be concentrated. Remember, if you go back and you look on this side, it tells you guys the side that is concentrated versus diluted, so make sure you use that. M, that should be really easy. I went over that, so think about what M stands for. Number 8, it tells you guys to calculate the ratio. You just did that. You just completed that on the other page, so that nothing actually has to be written on number 8. Number 9 asks for the mathematical equation. That's the equation that we asked you guys to write on the other side of the paper. You'll want to rewrite that mathematical equation for molarity over here on this side of the page.
Okay, I'm going to interrupt Mrs. Ammon.
Please do so.
So cross out number or 8A, but they do have to do 8B so that they understand the ratio concentration of the ratio compared to the molarity.
Absolutely, you are correct. 10 says what type of solution, dilute or concentrated, will have the larger molarity value. So your answer will be dilute or concentrated. So figure out which one will have the higher molarity value. Number 11, you're going to circle the correct answer. There are 3 options. You will circle the one to be the true statement. Number 12, ask you guys to explain how beaker 5 with fewer moles of glucose can have the same molarity as beaker 4. So one thing that you guys can think about is think about this mathematical equation again and put that into perspective when you guys are looking at comparing beaker 4 and beaker 5. And number 13, I gave you guys a good hint for that one when I was talking about filling out the equations on the previous page, so you may want to re-watch that part if you're struggling with number 13. Number 14 is asking you guys to calculate the molarity of a solution of 1.5 moles of sodium chloride in 0.05 liters of solution. So you're going to retake the same equation from 2 pages ago. It was also written on the last page, and you're going to take whatever number up here has moles and put it here, whatever number up here has liters and put it here, and you're simply going to divide those 2 numbers to get the amount of moles when the equation is done. You will complete that same process for number 15. Number 16 is asking if 40 or 74.55 grams of potassium chloride per 2,000 milliliters is in the correct molarity solution. You really need to think about the units of measurement in this one, okay? Think about those units of measurement and what units of measurement you use up here in order to help you answer number 16, A and B. 17 is a little trickier. So 17 is moving into the next part of the dimensional analysis that we are going to be working with you guys on. So next week when we post our next video, it's going to be going into a lot more of these examples. So it's asking you to calculate the molarity of a solution containing 2.5 grams of copper chloride in 1 liter of solution, and it asks you to show your work. I have on here PT because you are going to want to use your periodic table for this one. You guys can access one, Google any one you'd like to online. We're going to supply a picture of one for you with this so you guys can use it as well, but you will be referencing this. So number 17, how you're going to start is you're going to start by, we have 2.5 grams of copper chloride in 1 liter of solution. So you will write 2.5 grams of copper chloride over 1 liter. And now, in order to go ahead and to cross out 4-dimensional analysis, if we have copper chloride up front in the form of grams, we're going to need to have grams of copper chloride on the bottom. But how do we figure out the actual amount of grams in copper chloride? So what you're going to have to do is you're going to have to go to your periodic table and you are going to find copper. And when you find copper, you're going to go ahead and you're going to look up that mass of copper. So we have 23.546. Or 63.546. That was small. So I can go ahead and put 63.546 on the side because that is copper. And then we're going to look at chloride. And if we come over here and we look at chloride, you can see that it's 35.453. 35.543. But the thing is, that's one. We have two. There are two of those. So then we're going to add another one of 35.543. And then now you have the chloride, the two of them. We're going to add these numbers together. So if we take a calculator and we do 63.546 plus 35.543 and 35.543, we are going to get 134.63. 134.63. So we're going to go ahead and put 134.6 grams per copper chloride, and that is equivalent to 1 mole of copper chloride. And once you do that, you are going to cross out the grams of copper chloride, and that's going to give you how many moles of copper chloride you have. So you take, clear that out, the 2.5 grams, because it's up on top. You could divide by 1, but you don't really need to because it equals the same number. And then you could times by 1, but you don't need to because it's also 1. So you're going to take the 2.5, and because this number is on the bottom, you will divide by 134.6. And when you do, you are going to get 0.018, and we're going to round that up to 0.02. So it's 0.02 moles of copper chloride. And that 0.02 moles is over...
No, it's just moving your arm.
Oh, is over 1 liter. So we have this 1 liter. So we have moles up here and the liter here. That's over 1 liter. So if you go ahead and you take that and you divide it by itself, 0.02 over 1 is going to still equal 0.02. You have 0.02 moles total. And that's going to give you the answer to that equation. So you're going to use this, and we're going to challenge you to try to use that to complete the equation on this page for number 20. So you're going to have to go back and you're going to have to look at that mass on the periodic table in order for you guys to do that. For number 19, think about what I talked about, how not every lemonade's going to look just like that. They can look different ways, and that can be the differences between concentrations and dilutions. And for number 21, you're going to go ahead and make some kind of a solution on your guys' own with 21, 22, and it can be a tea, it can be sugar and water, it can be lemonade, anything along those lines where you guys are making that aqueous solution, and you guys are going to use the term solute, solvent, solubility, concentration, and dilution, and you are going to describe how somebody will go ahead and create that mix. Do you have anything else you'd like to add, Mrs. Egan?
No, I think you've done a very good job, Mrs. Ammon.
All right, goodbye, chemistry kids.
Out.